Hi, this is the 2004 AP Chemistry Free Response question number 2. The question is, iron reacts with oxygen to produce iron 3 oxide, as represented by the equation given. A 75-gram sample of iron is mixed with 11.5 liters of oxygen at 2.66 atm and 298 Kelvin. So part A asks us to calculate the number of moles of each of the following before the reaction begins. So first we are going to create solid iron. We are given the 75-gram sample, so we are going to do a simple stoich problem, and by using the molar mass, which is 55.85 grams, we divide by this number to find the moles of iron, which is 1.34. For part 2 of part A, we're going to find oxygen. Based on our givens, we can use PV equals nRT. Once you plug in your values, we find that the moles of oxygen is 1.25. Part B. Identify the limiting reactant when the mixture is heated to produce iron oxide. So to do this, we are going to use the moles of oxygen that we found and set up a molar ratio. Based on this, we find that there's 1.67 moles of iron. Because of our initial calculations, we found that there was 1.34. Since this is a larger number, that means that there is not enough iron to react with the amount of oxygen. Therefore, Fe is going to be our limiting reactant. Part C. Calculate the number of moles of iron oxide produced when the reaction proceeds to completion. So to do this, we are going to use our limiting reactant and use the molar ratio that was given in our equation to find that there is 0.67 moles of iron oxide. Part D tells us the standard free energy formation, delta G, of iron oxide is negative 740 kilojoules per mole at 298 Kelvin. Part 1 asks us to calculate the standard entropy of formation, delta S, of iron oxide. To do this, we are going to use the go home to supper equation. Once you plug in your values, we will find that the delta S formation is equal to negative 0.28 kilojoules per mole Kelvin. The second part of part D asks which is more responsible for the spontaneity of the formation of the delta H or the delta S. The delta H of formation is responsible. Because of the reaction being exothermic, we know that this will favor spontaneity. Based on our calculations from part 1, we know that delta S is negative. Therefore, it is more ordered as the reaction continues. If the order becomes greater, this will decrease the spontaneity of the reaction, which means delta S is less important. Part E asks us to calculate the delta H of formation for iron oxide. To do this, we are going to use our sum of products minus our sum of reactants. Based on our calculations from previous questions, we can plug in values. Once we plug in values, we find that the delta H of formation is negative 272 kilojoules per mole. Thank you so much for listening, and good luck on your AP exam. Thank you.